Question 3, quite a short one this one. We start off with 230 volts of voltage, or potential difference, 2.6 kilowatts of power, and we're going to work out the current. So we know what V is, the potential difference, we know what P is, the power, and we're trying to work out what I is, the current. So we need an equation with V, P and I, so it's going to be P equals VI or IV, doesn't really matter. Now the key thing with this, before you put the numbers in, is you've noticed that it's 2.6 kilowatts. Kilo means times this by 1,000. So 2.6 kilowatts times 1,000 is going to give us 2,600 watts. So we need to remember that our power is going to be 2,600 watts, not just 2.6. Once we've avoided that pitfall, we'll be absolutely fine. So we need to find out the current. To rearrange this to get the current, we need to divide both sides of the equation by V. So we'd have P divided by V is equal to I. So all I need to do is take the power divided by the voltage. So it's going to be 2,600. We'll put it over here, 2,600 divided by your voltage of 230. To show you that on the calculator, we have 260 over 230. That's going to give me 11.304 blah blah blah. So you're looking at 11 amps there essentially. In this question they did allow you the answer if your answer would round to 11. So they weren't going to penalise you for using the wrong number of significant figures in this situation. And if you got nothing else, by the way, you would at least get a mark if you mentioned your conversion here. So even if you don't know how to do the other bits, but you spot something that you can convert, that is sometimes good for a mark, worth a try. Part B, we have a power rating of 55 watts and we have a current of 4.4 amps, and we've got to state the equation relating power, current and resistance. So power of course is P, current is I, resistance is R. We need the equation with P, I and R. It's going to be P equals I squared R. If you use the mnemonics from class, that's pizza in square receptacle. Yeah, so just literally giving that equation will give you the mark for that, of course, and then calculate the resistance of the headlamp. We've got to find out what R is, and we know what P and I is. So to get R, we just need to divide through by I squared, so we have P over I squared is equal to R. There we go. So your power is 55, and we divide that by the square of the current, which is 4.4 squared. Now I've just put that in brackets just to be absolutely sure that everything at the bottom is at the bottom, nothing weird happens. So I've got 2.84090. Show you what the mark scheme says. It's looking for you to say 2.8 ohms. Remember, of course, it's ohms because it's going to be resistance. And again, they've been quite nice. They've said allow answers that round to 2.8. So they weren't going to penalise you for significant figures or not rounding properly this time round. So yeah, mark for substituting numbers in, mark for rearranging. You could do that in either order, as you can see here. I did the rearranging first and then I put the numbers in, because I usually find that if you put the numbers in, it makes it a little bit easier to make mistakes. But as long as you do it correctly, you can get it right either way. And yeah, it says 2.8 ohms, and that is that.